All right, guys, here's our final lesson of the year. This is a review for chapter 14. You can find this review in the notes section of OneNote under chapter 14 in the content library. Basically, I've just put these bullet points here, and I'm just going to talk about each one real quick, and hopefully you'll be able to get all the information you need to do well on the test on Friday. All right, so you need to know what ions are in pure water. Remember that H2O, it will ionize into H plus OH minus. Remember, H plus is actually H3O plus. They're the same thing. So these are the ions found in water. So all water samples have H plus and OH minus in there. Small amounts, but it's there. The concentration of ions in pure water, so OH minus and H plus, both have a concentration of 1.0 times 10 to the negative 7 at 25 degrees Celsius. So that's its molarity, or its concentration. Remember, concentration shows up as these brackets like this sometimes too. The ion product constant of water, in other words, if you multiply these two guys together, you'll find that the ion product constant of water at 25 degrees Celsius is 1.0 times 10 to the negative 14, and that equals the concentration of H plus times the concentration of OH minus. Acidic and basic solutions are based on their concentrations of ions. If there are a higher concentration, the concentration of H plus is greater than the concentration of OH minus, then we're going to say it's acidic. And if the concentration of H plus is less than OH minus, then we're going to say it's basic. So if it has more OH minus, it's basic. If it has more H plus, it's acidic. The pH of pure water at 25 degrees Celsius is 7 because the negative log of its ions, number of ions, which is 1.0 times 10 to the negative 7, if you remember that from up here, the negative log of that is equal to 7. So pH. Calculating the pH from hydronium concentration, that's this guy right here. The pH is equal to the negative log of whatever the concentration of H plus is. So this could be given as 1 times 10 to the negative something. It could be given as a value times 10 to the negative something, or it could be just 0.004. If you were to do that, then you could plug that in your calculator and find the pH. Calculating the pH from a hydroxide concentration is a little different. You have to find the pOH first, which is the negative log of the hydroxide concentration. And then what I usually do is just take 14 minus the pOH is equal to the pH. Now the reason we know that is because we know the pH plus the pOH is always equal to 14. So if I subtract the pOH from 14, that gives me the pH. Calculating concentration from pH, if you are given a pH to find the concentration, it's all we have to do is take 10 to the negative of that pH, and that will equal the concentration of H plus. So that's your anti-log function, or second log on your calculator. You throw that in there as the negative pH, and that will give you your concentration of your hydronium. There are 3 acid reactions that you need to be familiar with. It's acid plus base is the first, and that's going to give you a salt plus water. An acid plus metal, that's going to give you a salt plus hydrogen gas. And an acid plus a carbonate, and that's going to give you a salt plus water plus CO2 gas. So that's a gas, and this one's also a gas. So those are your 3 reactions. There's more than that, but for this class we're just going to stick to those 3, and that's just something you have to memorize. Remember, a carbonate is something with CO3 ions in it. So 3O2, CO3 2 minus. Electrical conductivity, both acids and bases Acids and bases contain ions. Therefore, they conduct electricity. Properties of acids and bases. Remember that acids, not only do they all conduct electricity, both acids and bases, but acids are sour. Bases are bitter. And bases are slippery. All right, you need to remember your three theories. The Arrhenius theory is anything that increases H plus or H3O plus, which is the same thing. Anything that increases H plus ions is an acid. Anything that increases OH minus ions is a base when put in water. Bronsted-Lowry, an acid, is a proton donor, and a base is a proton acceptor. Lewis is looking at electron pairs in reaction. So an acid is an electron pair acceptor, and a base is an electron pair donor. Okay, keep rolling here. Strong versus weak acids and bases. A strong acid completely dissociates in water. So a strong acid like HCl in water would form H plus and Cl minus ions. These would be aqueous completely. So the arrow only goes to the right. Whereas a weak does not completely, so only slightly dissociates in water. So something like CH3COOH only slightly, so we have this reversible arrow, so there's just a few H plus ions and then CH3COO minus aqueous. And so because there's a reversible arrow here, that means it's weak because it only makes a few ions. So strong versus weak is based on how fully it dissociates. Conjugate acids and bases. Conjugate base is what the acid becomes after donating its proton. Right? And a conjugate acid is what the base becomes when, or after, we'll use the same term there, after accepting a proton. And then the last thing that you need to know for the test on Friday is our neutralization reaction for a titration. So if we have something like NaOH plus H2SO4, we have to balance the reaction. That's going to form Na2SO4 plus H2O, and we're going to need two of those guys to balance that, and so we would need two of those as well. And so we balance it out. So the equation we would use, since this is my base and this is my acid, we would use MAVA equals MBVB divided by 2 because of that guy right there. So we might give a question about this. We might say an unknown concentration. So we'd say the concentration of the sulfuric acid is unknown, but we have 25 milliliters of it. and then we might be given that it took 10 milliliters of this sodium hydroxide, and it was 1.00 molar. So then we would just plug in what we'd know. We'd say the molarity of the acid times its volume, which is 25.00, equals the molarity of the base, 1.00, times 10, divided by 2. So we would multiply both sides by 2. That would give us 50 MA equals 10. We would divide by 50. And so we would find that MA is equal to 0.200 molar. And that would be our answer there. So that's a neutralization problem. You guys got a lot of practice with those and the other calculations in your worksheets. So hopefully you get how to do all these. Make sure you keep track of that class calendar. Everything that is happening this week is on there. And so if you're keeping track of that, you'll see that today is Wednesday and it's the Chapter 17 review. I am going to hold office hours tomorrow if necessary. It's going to be upon request. So if you would have any questions, feel free to shoot me an email and then we can jump on and I can help you with whatever you might need. And then on Friday, which is the last day of school, you guys will take your Chapter 17 test and be done from there. So I hope everyone continues to do well, have a fabulous summer, and remember next year to swing by and say hi.